In this class, we will discuss about Kirchhoff's voltage law. Kirchhoff's law are two types. Number one is Kirchhoff's current law, and number second is what? And Kirchhoff's current law is also called what? Kirchhoff's first law. Kirchhoff's current law is what? Kirchhoff's first law. And Kirchhoff's second law is what? Kirchhoff's voltage law. Kirchhoff's current law is what? KCL. KCL is the abbreviated of Kirchhoff's current law, and KVL is abbreviated of what? Kirchhoff's voltage law. So in the last class we studied about the Kirchhoff's current law. I am just revising this law. What is this law? At the node in the circuit we are having nodes. What is the node? Node having two or more branches intersecting. Node is a point. What is the node? Node is a point and two or more branches are intersecting. Two or more branches are intersecting. That point is called what? Node or junction. So at the node, incoming current must be equal to what? Outgoing current. At the node, incoming currents must be equal to what? Outgoing currents. That one is what? Kirchhoff's current law. But Kirchhoff's second law is what? Kirchhoff's voltage law. And in this class we will discuss about this law. So what about this one? Once we are having closed circuit, then this law is applied. Are you getting what I am saying? Closed circuit we are in. Circuit is what? Circuit is what? Circuit is a closed path and some elements consist. Circuit having some elements and it is what? Closed path. So in the circuit we will apply both KCL and KVL. We will apply in the circuit to simplify the circuit. Circuit is complicated. We want to some physical quantities like voltage, current, values. Then we want to simplify that circuit. Then these laws KCL and KVL are most important. By using these laws, we will simplify the circuit, then we can find to required result. So, in the circuit is a closed path. So, at the node, once we are getting the node in the circuit, then we will apply KCL. But we want to, what? Voltage. Node KCL is what? Based on the principle of conservation of the charge. KCL is based on the principle of conservation of the charge, but KVL, Kirchhoff's voltage law, is based on principle of conservation of energy. Kirchhoff's voltage, Kirchhoff's current law, and current is what? Flow of charges. So it is based on the principle of charges, conservation of charges. But KVL is based on principle of conservation of energy. Why? Because in which we are having Kirchhoff's voltage law, and voltage is what? One source. In the circuit, this is what? Voltage source. This is cell, and cell is having energy. Energy is stored in the cell. So it is what? Voltage source. It is having energy. So this KVL is based on the principle of conservation of energy. What is the law of the conservation of the energy? What is the law? Energy. What is the conservation of the energy? Energy, what? Observe. Energy can never be created nor be destroyed. What? Conservation of energy. Law of the conservation of the energy. Energy can never be created nor be destroyed. It will converted from one source to another. Only it is a conversion. We cannot create energy and we cannot destroy energy. Only it is converging from one form to another. So conservation of energy, what? Energy can never be created nor be destroyed. It can be converted from one form to another. That is what? Conservation of energy. Clear? So KVL is based on conservation of energy. Now what is KVL? Kirchhoff's voltage law is what? KVL is what? What is its statement? Observe, states that algebraic sum of voltage in a closed loop is equal to 0. This is the closed circuit. Circuit was closed loop. In the closed loop, algebraic sum of voltage. What? Algebraic sum of the voltage. Algebraic sum of voltage in a closed loop is equal to what? 0. Summation of V, sum of voltage in a closed loop will be equal to 0. That is what? Kirchhoff's voltage law. Kirchhoff's current law is what? It is applied at the node or junction of a circuit. What about the node or junction? A point where two or more branches are intersecting, that is called node. And that node, incoming current must be equal to outgoing, that is what? KCL. But KVL applied in the closed loop, and in that loop sum of voltage equal to 0. In the KCL, sum of current equal to 0. But in the KVL, sum of voltage equal to 0. How? Like this is what? Series circuit in which R1, R2, R3 three resistors are connected in the series. Dropage, voltage drop across this one is V1, voltage drop across this one is V2, and voltage drop across this one is V3. Why? In the series circuit, current will be the same in all three elements. R1, R2, R3, current I is flowing. From this source, current starts. What is the current? Current is the flow of the charges. So this current I starts from positive terminal of cell to negative terminal of cell. This is the basic idea. In the circuit, current starts from positive terminal of battery to negative terminal of battery. Clear? So in all elements R1, R2, R3, current I is flowing. So all are having same current. We studied Ohm's law and V equal to IR. What is the Ohm's law? We studied already. V equal to IR is Ohm's law. I is the same in all resistors. I is same, but R value is different. 1 ohm, 2 ohm, 3 ohm. They are connected in the series. Clear? Then how we will find the voltage? Product of current into this one. So V1 equal to what? This, in this element, in all elements, current I is flowing. Clear? This is the direction of the current. So from current starts from positive terminal to negative terminal. In all elements I is flowing. It means this one is having I R1. So what will be the dropage? I R1 for the R1 resistor. Observe. First thing, current starts from positive terminal of battery to negative terminal. Second thing, whenever current enters to the any element, observe this current I flowing and entering to this resistor R1. Entering point will be what? Positive. Leaving point will be what? Negative. Again this current I is entering to R2, entering point will be positive and leaving point will be what? Negative. Again current I is entering, so positive, leaving, so negative, and again coming to negative terminal. So current starts from positive terminal to negative terminal. In any elements, current entering means that terminal will be what? Positive, and leaving means what? Negative terminal. Clear? Now in all elements current is I is flowing, but voltage will be the different. V1, V2, V3 values will be different. So in the series circuit, this is a series. Why? Because current is same, but the voltage will be different. Now this is the closed loop. We want what? Voltage. Voltage across these all element, voltage is V, not V. This source is what? V. This element having voltage V1, different voltage. Current is the same. Current I is flowing in these elements, but voltage will be the different. V1, V2, V3. So what will be the KVL? So how we will find KVL statement? So KVL statement is what? Sum of different voltage we are having. In this closed circuit, current is the same, but voltage is the different. Total source, this is the main source, and once we apply across these elements, then each element having different voltage. It means this source will be equal to sum of these. Directly we can say. Why? Because sum of these will be what? Total. This one will be equal to this one. So that is the KVL. Observe. But In statement form, one statement we are having, KVL states that algebraic sum of voltage. Algebraic sum of voltage in closed loop. This is the closed circuit in which sum of the voltage. KVL apply where? In the closed circuit. In the closed circuit, sum of voltage. Sum of voltage will be what? 0. That is what? Kirchhoff's voltage law, KVL. KVL is applied in a closed circuit. In the circuit, sum of voltage will be 0. That is what? Sum of algebraic sum of voltage in a closed loop is equal to 0. That is KVL. This will be its statement. Clear? So, how we will write equation of voltage? Voltage equation how we will develop? So, whenever current enters to the negative terminal, then sign of current will be sign of current, sign of voltage, but in which we are taking voltage sum. So, sign of voltage will be positive, and when current enters to the positive terminal, then sign of voltage will be negative. Observe what I am saying. Now this current I is flowing in this circuit. Now current I is entering to negative terminal. So voltage sum we want. So sum of voltage. Sum of voltage, it means we will take each voltage. So this voltage will be, current is entering to negative terminal. So sign of voltage will be what? Positive. We will take positive. Now this is positive, this is positive, this is positive. Current is entering to positive terminal. It means sign of voltage will be what? Positive. So negative we will take. We will take negative, negative, negative. Observing or not? Once current entering to negative terminal, sign of voltage will be positive. Sign of voltage will be positive. Current enters to the positive terminal, then sign of voltage will be what? Negative. So current is entering to negative. So we will take plus V. Current is entering to positive, we will take minus V. Current is entering to positive, so we will take minus V2. Current is entering V3, so what? Minus V3. Observe, in which current is entering to negative terminal, sign of voltage will be what? Positive. For the V1 source, current is entering to what? Positive, the sign of voltage will be what? Minus V1. There is the positive, so sign of voltage will be what? Minus V2. Positive, sign of voltage will be what? Minus V3 equal to 0. Sum of voltage. So, in short we can say, in the closed circuit, sum of voltage equal to 0. Once current is entering to positive source, positive terminal, then sign of voltage will be negative, and negative, current is entering to negative terminal, then sign of voltage will be what? Positive, and sum of these all will be what? 0. So once we solve, we are getting this one. This will be, these all are negative, so we can transpose towards the where? In the right side. So V1, V2, V3 will be in the right side. We are getting this. So V equal to V1 plus V2 plus V3. So in another way, we can say, in the KVL, sum of voltage rise must be equal to what? Sum of the voltage drop. V1 is what? This one. Observe this one. This is the minus 2 plus. So it is voltage rise. Increasing voltage, sum of voltage rise, only this one, remaining plus V1, V2, V3, 3 source we are having. So these are what? Decreasing voltage, plus to minus, plus to minus, plus to minus. So V1, V2, V3 are decreasing. So voltage drop, sum of voltage drop. So we can say voltage rise must be equal to voltage drop will be what? Kirchhoff's voltage law. From this we can say, after this one what? Main statement we are having, algebraic sum of the voltage in a closed loop will be what? 0. Clear? Current entering to negative, we will take sign of voltage will be positive. Current entering to positive terminal, then we will take sign of voltage will be negative. Once we solve, we are getting, and what is the meaning of this one? Voltage rise. V is what? Rising voltage. Rising voltage we will take one side, and droppage, voltage droppage we will take another side. So we can say this is a rising, so V1 will be equal to V1 plus V2 plus V3, this one. So this is what? Kirchhoff's voltage law. So simple. So we studied this thing. So normally I am revising Kirchhoff's law. In our syllabus we are having two Kirchhoff's laws. Kirchhoff's first law, KCL, Kirchhoff's current law. It is applied at the node in a circuit. Incoming current must be equal to outgoing current. Second law, Kirchhoff's second law is what? KVL. It is what? It is applied in the closed loop. sum of voltage in a closed loop will be equal to 0. When current entering to negative terminal, sign of voltage will be positive. Entering current into the positive terminal, then sign of voltage will be negative, we will consider, and sum of these will be what? 0. And finally we can say voltage rise must be equal to 0. Sorry, voltage rise must be equal to voltage drop. Voltage rise means minus to plus, dropage means plus to minus, plus to minus, plus to minus. So this is what Kirchhoff's laws, Kirchhoff's voltage law. I hope you understand these things. That's all about this class. Thank you so much.